We have had some good luck with the SERVANT RISC-V processor. Um, we're now able to have the LED 0 and 1, which flash, and I was also able to measure it on this signal with my oscilloscope, and so it's on for about 2 seconds and off for about 2 seconds. So that's the rate at which it toggles. I also instantiated my Blinky, which is a counter, and I had it counting, so it was high for 2 clocks and low for 2 clocks. So that the clocks, and I confirmed that the clock is running at 50 megahertz. Um, yeah, so the struggle that I had with the last video was how do you assign the hex file, which contains the program, the instruction RAM, how do you assign that to the FPGA? My plan had been to go in and use this right here. Oops, this configure design initialization data memories. So I had planned on double clicking on that and going into here, and then all the different memories that are in the system. And we're dealing with is the fabric memory. And I thought that I could scroll down through, find their Savant memory, um, and then uh, how would you do that? Select this, right? Maybe double click on it, and then you can put in the name right here, content from file. You can put a content from file. That's what I planned on doing. Um, Two problems with that. The hex file we have is not an Intel hex format. It's basically a bunch of hex digits, um, uh, 8 hex digits, 4 bits per hex digit, which is 32 bits per line. And so each line is associated with the memory. So, um, so we could not use this program. Also, the tools placing around synthesis broke the RAM up into 4 separate 8-bit wide memories. 7 down to 0, you can see the width. So we got the 0, 1, 2, and 3. And so somehow we would have to, if we use this tool, break that program, which had it in like um, 8 hex digits per line. We'd have to create 4 memories with what, 2 hex digits, 8 bits per line. So that's getting kind of not the direction that we wanted to go. So I had two other thoughts which I wanted to try, and so that would have been going in and editing the servant underscore RAM file, which is where which is where this memory is instantiated. So when we go to that, the two ways that I thought that we could do it, and I've done on other FPGAs, is one of them was using the read memh, and basically you specify the name of the file with the hex program in it and the memory that it goes into. So that's what I started with. I struggled with that for a while. I failed. I think I'm having a difficulty with the path. Thinking on it now, I could probably maybe look in the SIR file for maybe some error messages telling me where the path is. But right now, I do not know what the path is for blinky.hex. I put the file into the same place as I had my source RTL servant underscore RAM. That doesn't seem to have worked. Maybe it needs a little tweaking or playing around with, but right now, so I gave up on that path. And then what I ended up doing was I modified this initial statement. What do we got? Control Z's. See, well, it's not going to let me do it. Control Z, Control Y. I undid all my changes. Oh well. So we can redo the changes again. So here, these are currently commented out. So X, go up to here, it'll begin. So that says begin. And RHON. Let's try it again. Begin. Um, and 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 not too fond of this editor. Control V, but it gets the job done. Comment out the read mem H, which wasn't doing much for us. And now what we're going to do is we're just directly assigning into this memory at time 0 at the beginning of that, essentially a power up. We're assigning these values, these 32-bit values, into the memory. So I did a quick little sed that converted this file, which really just had these hex digits, into these lines. I did it with the command line sed program. I have a sed video which shows you how that's done if you're interested, or you can just do whatever you need to get it into this format. The memory is the memory. Address is 0 through 10, so there's 11 locations. And don't forget the 32 tick H, defining this as 32 bits of hex data. Equal sign and a semicolon. All right, put that in there, forget a begin and an end, which the original program didn't need or didn't have, and it didn't need. But now that we have a bunch of statements, we do need a begin and an end, and then compile this, and that's what got it to work. There's not much to see. It blinks slowly again. Like I said, 2 seconds on and 2 seconds off. Um, and is there anything else worth saying about this? Okay, so let's just take a quick little look at the reports. Um, so this this tab here for reports. Uh, let's go into synthesis. Let's see. Let's look at a netlist hierarchy resources. And so these are the hierarchical blocks of which you can click on the resources. Um, so you can see Servant is here. And here's my Blinky, which is just it blinks it blinks quickly. So that's pretty small using 3 resources. But Servant's pretty small too, just using 386 4 input lookup tables. And it's using 253 D flip-flops. And more stuff there. And here is interesting. We're using 5 LS RAMs. So that's an LS RAM, it says there, is like 20K bits, 20,000 bits, which is like a 20 by um, uh, 1,000 entries of 20 bits each, which can be also restructured into, it's fairly configurable, so you could have it 8 bits wide and have like 2,000 addresses, or like uh, like like 40 bits wide or 32 bits wide and have like 512. So it's a nice little RAM that can be reconfigured. What we're using it for is 8 bits wide for each one. Um, in reality, I would think that you should be able to put all, like I have it 32-bit wide. So with this Blinky, it's just 11 locations. So we could have just probably gotten away with just 1 RAM instead of the 4 RAMs that we saw in the previous table. And then we have a 5th RAM, which is the register file memory. So that's how the memory is being used. Um, and that's probably the most of interest, that's the report. Again, it's working. I'm kind of happy with it. Uh, so I think that's the end of this tale for the serve. Two directions I want to go in next are I want to be able to compile a C program into hexfile. Looks uh, like the Blinky example that was provided in the Git repo was using assembly language. So I could poke around with assembly language and get an assembly program assembled into a hex file. That would be cool. I still want to poke around, most importantly, figure out how to get read memh work. That's the proper way of doing it. So I have to figure out what folder, what path the Blinky has to be stored in. Um, and I think that's about it. Yeah, bye.